Hello, welcome to Mystery Science. Today we're going to be talking about balancing equations, and I'm going to show you how I would go about balancing equations. I'm going to try and demonstrate to you some of the pitfalls, some of the common misconceptions, what you can and cannot do when trying to balance equations. I'll show you some of the things I've seen students do that are a mistake, and I'll show you how to correct them and how to visualize what we're doing. So let's start with a very simple equation. Whenever you're asked to balance an equation, you'll probably have the skeletal equation already. Now, you do need to have some kind of idea of how molecules work and how they're bonded together. That's not necessarily important for the balancing of the equations, the mathematics behind it, but it does give you an idea of what's going on. And I think sometimes that's where students get hung up. They understand what it is they have to do, but they don't understand why they're doing what they have to do. And that causes some of the problems. So let's have a look at a very simple example. Let's start with H2 plus O2, which creates H2O. So we've got some hydrogen plus some oxygen giving us water. Now, is this okay? We have to remember the conservation of mass law. Mass cannot be created, nor can it be destroyed. So you have to have exactly the same amount of mass at the beginning of a reaction and the same at the end of the reaction. And if we look at this, then we can see that actually at the beginning of the reaction, we've got 2 hydrogen atoms and 2 oxygen atoms. Those are my reactants. That's what I have at the beginning. Here is my product, water. In water, I've got 2 hydrogen atoms. That's what this means. H2, 2 hydrogens, and 1 oxygen. So what does this look like? Well, some people I've seen will draw a little diagram to help them. So they'll represent hydrogen as, I don't know, 2 white blobs, and oxygen as 2 darker blobs, like this. And then they'll draw their water. So we have 1 hydrogen, 1 oxygen, which is a dark blob, with another hydrogen. And this is all well and good, but it's quite difficult then to rearrange them all. So the traditional way to do this is to write out how many atoms you have on each side. So over here I have 2 hydrogen atoms and I have 2 oxygen atoms. And on this side of the equation for my products, I have 2 hydrogen atoms and only 1 oxygen atom. And the idea for balancing equations is to get all of the atoms on this side equal to the atoms on this side. Because the conservation of mass law applies, you have to start with the same atoms and types of atoms as you finish with. If I start with 2 hydrogen atoms, I need to have 2 hydrogen atoms in my product. And if I've got 2 oxygen atoms in my reactants, I need to finish with 2 oxygen atoms. So this isn't going to work. This isn't balanced. So what do we do? Now, let's first look at the things we can do. And I'm going to make this easier on myself by representing this with these cool little Lego blocks. So here is my oxygen molecule, and here is my hydrogen molecule. Now, each one of these is made up of 2 blocks. I lie them down, they're 2 square blocks, and I put them together to make the molecule. These are my reactants, my hydrogen molecule and my oxygen molecule. Now I'm going to make one of these nifty water molecules. So as you can see, I have 1, 2 hydrogen atoms, 1, 2 oxygen atoms, and I've got 1, 2 hydrogen atoms and 1 oxygen atom. But this example shows clearly that it's not correct. I'm missing an oxygen atom. So one thing I cannot do is I can't simply add an oxygen atom. I can't just have that left over. This would be balanced, but not chemically stable. Oxygen must exist in a pair. It's got to bond with either another oxygen atom to make O2, like this. But if it does this, now there are 3 oxygens over here and only 2 over there. Plus, that wouldn't be a reaction. That would be creating water out of hydrogen from nowhere. So we can't do that. We can only multiply our reactants. And what do I multiply our products? What do I mean by that? Well, at the moment I have 1 water molecule. If I have another water molecule, I've now got 2 oxygens, which is what I want, and 4 hydrogens, which seems a little excessive. And to write that down in our formula, we add a 2 at the front. We cannot change any of the numbers at the bottom. Changing numbers at the bottom is changing the molecule. Okay, so I could not do this and make H2O2, which would make that chemically balanced, but that is not how you make hydrogen peroxide. It simply won't work like that. But here we go. I've now got 2 water molecules. So let's update this. I've now got 2 oxygens. Hooray, that's what I need. That's balanced, right? But unfortunately now I've got 4 hydrogens. So I have to come over and look at the reactants. What can I do over here to make this balanced so that I've got 4 hydrogens? Well, I can add another hydrogen molecule. Remember, I can only add multiples of these. So if I put a 2 at the front there, now my equation is balanced. I have got 1, 2, 3, 4 hydrogen atoms. And on this side I have got 1, 2, 3, 4 hydrogen atoms. Let's just update this. And I have 1, 2 oxygen atoms and 1, 2 oxygen atoms. So I've got the same on either side. I've now got 4 hydrogens here and 4 hydrogens there, 2 oxygens here and 2 oxygens there. Remember that this is what happens before the reaction, and then during the reaction what's actually happening is these 2 hydrogen molecules are reacting with this 1 oxygen atom molecule. So what's happening is the hydrogen is breaking apart, bonding with the oxygen like this. I appreciate that actually you're just seeing my hands. And this is what you're left with at the end. So while you're revising and you're thinking about balancing equations, if you've got little Lego bricks, it is worth just having a go and working out if you've got the same at the beginning. If you can make your product from your reactants with nothing left over with your Lego blocks, then you've done it right. Obviously you cannot take Lego into the exam, as fun as that would be, but while you're revising and while you're training yourself to balance the equations, you can use it as a really good check to make sure you're doing it right. So I'll show you that again. I have 4 hydrogens, 2 hydrogen molecules, 2 H2. Okay, there they are, 2 hydrogens, and 1 oxygen molecule. Okay, 2 oxygen atoms. I'm trying to make water. So I can split this apart, split these apart, and in my reaction, my hydrogen atoms bond with my oxygen atoms. I have nothing left over. I have 2 water molecules. Okay, so that's proof that my system works. You could of course draw this as well. So you can say, right, well I need 2 of these. Now I've got 2 oxygens and I've got 2 oxygens over here, great, but I've got 4 of these now. So you could draw those over there, and it's the same thing. And you can do this in your exam. You can draw the sketches to see if you've got it right in your exam. The problem here is, of course, that it's just not very flexible. If you get this right, that's fine and dandy. But if you get that wrong, then you can easily see that you've made a mistake with the Lego. So it's about finding a way to help you remember. It's also worth pointing out here that if you do use the Lego method for revision, that you don't rely on the Lego when you get to the exam. But the idea is you do this enough times that you convince yourself, or you know in yourself, that you can balance these equations, and so you don't have to rely on these Legos anymore. At the Haber process, making ammonia from nitrogen and hydrogen. So we start with nitrogen molecules. These are N2. Okay? And we add these to hydrogen molecules, which is H2. And this makes ammonia, or NH3. And you can see that immediately we've got the same problem. And here's what I mean with the Lego if we're going to try things. This time I'm going to use red to be nitrogen and white to be hydrogen. Okay, so I have an N2 molecule and I have a hydrogen molecule. So can I make NH3? So I break these apart and I see if I can make NH3. So I've got I have N, H2 and a random N. Okay. So this doesn't work. I cannot make this with this. So what can I do? Well, the first thing I want to do is I need more hydrogens. And I've got 2 nitrogens. So I'm going to need to make at least 2 of these molecules. So I can try that. And I find that actually sometimes if you're just doing it with pen and paper, the best thing to do is do it with a pencil. Otherwise there's lots of scribbling. But let's crack on with this because I've only got a pen handy. So I'm going to make 2 ammonia molecules, 2 NH3. This means I'm going to need 6 hydrogens, and I'm going to need 2 nitrogens. 2 nitrogens I have, that's fine. To make 6 of these, I'm going to need 3 hydrogen molecules. So let's see if that works. Okay, so can I make 2 NH3s from this? So if I break apart my nitrogen and I add my hydrogens on, it's looking very good. There we go. 2, because there's 2 of them, N, H3, 1, 2, 3, NH3. Okay, so that's what we're doing with balancing equations. We're making sure that what we start with, we end up with. I did not add or take away any of these little Lego blocks when I did the reaction. That's the crucial thing. While I'm doing the initial equation, that reaction couldn't happen. When I just had N2 plus H2 gives NH3, that reaction simply could not happen. That was impossible because there was not enough hydrogen and I ended up with too much nitrogen. So it just wasn't chemically viable. But when I jiggle around the number of molecules that I need, that's when it works. Now, if you're confused about adding more molecules, remember that these processes aren't on their own. We don't actually just take 1 nitrogen molecule and 3 hydrogen molecules and make 2 ammonia molecules. That would be crazy. But what we do is we have a very large amount of nitrogen gas just floating around in a canister, a very large amount of hydrogen floating around in a canister, and then we just react them together, and then we get a quantity of ammonia. Now, if you just let that happen, you're going to end up with a lot of wastage. You're going to end up with a lot of unreacted nitrogen and a lot of unreacted hydrogen, and not as much ammonia as you would like. But if you as a chemist and an industrial chemist knows the full balanced equation, so your industrial chemist would say, for every 1 mole of nitrogen gas, I would use 3 moles of hydrogen gas to give me 2 moles of ammonia gas. Now, if you are confused about the concept of moles, then check out the video that's coming up soon on my CC9 series about moles. But if you're looking at reacting masses, I've got a couple of videos on those, on empirical formula and calculating reacting masses, and we use the same terminology there. So in order to do those effectively, you need to be able to balance equations. So let's have a look at some more examples. We're going to have a look at some methane, which is CH4, and we're going to burn that in the presence of oxygen. That, as always in perfect combustion, is going to give us some carbon dioxide and water. Okay, because that is the product of combustion. That is a thing. So this is where it's going to get tricky Lego wise, but I am going to use this little yellow thing as carbon, and my white as hydrogen, CH4 plus O2, and then I've got CO2 and H2O. CH4 plus O2 giving CO2 plus H2O. Now we can immediately see that this isn't balanced. I've got 2 hydrogens over here, I've got 4 over there, and I've got 1, 2, 3 oxygens there, and I only got 2 over here. So what is the most logical thing to do? And the tricky thing here is, and I notice students get hung up on this all the time, is, well, where do I start? What is my starting point? So I always start with the thing that I don't have enough of. So over here I've got the same number of carbons on either side. I would quite like to leave the carbons well alone. I've got 4 hydrogens over here, but only 2 over here. So I'm going to need another molecule with hydrogen in. So I'm going to need at least 1 more water molecule. Okay, so now I've got 1, 2, 3, 4, which is what I need. 1, 2, 3, 4, that's perfect. But now I've got 1, 2, 3, 4 oxygen molecules. So what do I need to do? Well, I need more oxygen on this side. There we go. I am pretty sure that I could make this from this, but let's write out what we've got. I've just put that on my head. So let's write out what we've got. We have 2 water molecules and we have 2 oxygen molecules, and this is now balanced. The best thing to do as well is to just check, take the Lego away and check you've got the same number of elements on each side. So we do that by doing a little element audit. Carbons, I have 1 on this side. Carbons, I have 1 on this side. Hydrogens, I've got 4 there. Okay, and hydrogens I've got 2 times 2, which is 4 over there. Oxygens I've got 2 times 2, which is 4. And oxygen here I've got 2 there and 2 there. So that is 4. Remember what these symbols represent. If there is a large 2 at the front of a molecule, that means there are 2 of that molecule. So if I have 2 H2O, that means there are 2 water molecules, 2 times H2O. Okay? If the number is a little subscript down here, H2O, that means there are 2 hydrogens in that molecule. So here's the one molecule with the 2 hydrogens and 1 oxygen, H2O. It's 2 H2O when I have 2 of them. Okay. Similarly over there, 2 O2, I have 2 O2 molecules. Here I have CH4. H4 means I've got 4, 1, 2, 3, 4 hydrogen atoms in that molecule. And CO2, I've got 1 carbon, 2 oxygens. So as you can see, I can make that from that, and that is balanced. And that's all we're trying to do. So if you've got this some Lego sets knocking around and you're trying to revise how to balance equations, I thoroughly recommend doing this. Let's do a few without Lego. So let's crack on with the easier 5. Here are 5 equations. I would like you to pause the video and attempt to balance those. We've got nitrous oxide breaking down to nitrogen and oxygen. Then we've got hydrogen chloride or hydrochloric acid breaking down to hydrogen and chlorine gas. Then we have PCl5 breaking down to PCl3 and chlorine gas. Then we have C2H6 breaking down to C2H4 plus H2, and carbon and oxygen giving carbon monoxide. So pause the video and have a go at those. Right, welcome back. So let's see. Our first one then is maddeningly easy. I'm hoping that you can either see it straight away or you can appreciate that it's obvious once you know how to do it. So my method for doing this is this. I start with one of the elements that I know I need more of. So over here I've got 1 nitrogen and I need 2. So the first thing I'm going to do is I'm going to pop a 2 in the front and say I need 2 nitrous oxides to get 2 nitrogens. But now I have exactly the right number of oxygens. I've got 2 nitrogens and 2 oxygens, and I've got 2 nitrogens and 2 oxygens. And we can check this out using the Lego. I should actually be calling these building blocks. Sorry, not the brand name. So there you go, I've got 2 nitrous oxides, and if they decompose to 1 oxygen and 1 nitrogen molecule. Perfect, job done. So I've got hydrochloric acid breaking down to H2 and Cl2, so that's hydrogen gas and chlorine gas. And you can see that this is exactly the same. I need 2 hydrogens, I need 2 chlorines, I've only got 1 there, so bam, there we go. For every 2 moles of hydrochloric acid, or for every 2 molecules of hydrochloric acid, I'm going to create 1 molecule of hydrogen and 1 molecule of chlorine. What about the third one then? Now, at first glance, this might seem really tricky, but it isn't. If you do the audit of elements to start with, we have 1 phosphorus here, and we have 1 there. We've got 5 chlorines over here, we've got 3 chlorines here, and 2 chlorines here. So if we add those together, we've got 5 chlorines and 1 phosphorus. And over here we've got 5 chlorines and 1 phosphorus. This is literally what's happened. You have, what's that, 1, 2, 3, 4. So I've got 5 chlorines, 1, 2, 3, 4, 5, and 1 phosphorus, and it's decomposed into that. PCl3, 1, 2, 3, and Cl2, 1, 2. Simple. So that equation is already balanced. So C2H6 decomposing to C2H4 plus H2. Well, as you can see already that there are 2 carbons on this side, 2 carbons on this side. There are 4 plus 2 hydrogens, that's 6 hydrogens, and 6 hydrogens, so these again are already balanced. Our final one then, carbon plus oxygen gives carbon monoxide. So here we go, here's our carbon atom and our, stay there Mr. Carbon, but you end up, sorry, 1 carbon and 2 oxygens, and that's going to create carbon monoxide, but that's not going to work because I have this extra one. That's not okay. I cannot destroy molecules. So what I do instead, I've got 1 carbon over here, I've got 1 carbon over there, that's fine. I've got 1 oxygen, I want 2 oxygens. So I make this so that I've got 2 oxygens, so I multiply that by 2. But now I've got 2 carbons. So what can I do to remedy that? Well, I simply add another carbon. So now I can show that my 2 carbons and my 2 oxygen atoms will form 2 carbon monoxide atoms. So there we go. So those were relatively simple. All I had to do here was recognize that I needed 2 molecules to break down into these 2 separate molecules, and again 2 of the same molecule here to break down into these 2 molecules. These 2 were already balanced, and in this I needed to get 2 carbons to 1 oxygen molecule to make 2 carbon monoxide molecules. So let's try something slightly harder. Okay, so these are the medium ones. These are slightly harder than the ones you've seen before. You're likely to need to do some balancing here. So we've got C2H4 being burnt in the presence of oxygen and giving the combustion equation of carbon dioxide and water. Then you've got the same thing with methane. That should look familiar to you. CH4 plus O2 giving carbon dioxide plus water. And then we've got OF2, so oxygen and fluorine with water, and that will give you oxygen plus hydrogen fluoride. Then finally, next we've got F2 plus H2O gives OF2 plus HF. And if I just scooch out of the way, wrong way, here, ooh, look, I'm floating, ooh. You have methane plus sulfur, CH4 plus S, which gives carbon sulfide, CS2, plus H2S. So pause the video at this point, have a go at some of those, and I'll see you back in just a moment. Hello, welcome back. How did you get on? Hopefully you did okay. If not, don't worry. What I'm going to do now is I'm going to go through how I would balance them. I'm going to balance them on the paper, and then what I want you to do, if you've got any of these wrong, is pause the video when I've finished, have another go and see if you can get the same answer as me. Don't just copy my answer, that's not going to help you, but make sure that you can get the same answer that I did. Okay, so our first one, C2H4 plus O2 gives CO2 plus H2O. Well, the first thing I notice here is this C2. I don't have 2 carbons in the reactants, in the products. So the first thing I'm going to do is multiply that by 2. So now I've got 2 CO2s. So I've got 4 oxygens there, and I've got 1 oxygen there. So I've got 5 oxygens. That probably isn't going to work, but let's crack on. I've got 4 hydrogens here and only 2 here. So if I multiply these by 2, now I've got 4 hydrogens. But now look, I've magically solved a problem. whenever I've got a diatomic molecule, something like oxygen, which exists as 2 atoms, I always want to have an even number in the product. So before I had 4 here and 1 there, which made 5, so I knew that wasn't going to be right. But now that I have 2 H2O here, now I've got an even number, and that gives us a little bit more hope. So I've got 4, 5, 6 oxygen atoms now. So how do I get 6 oxygen atoms in my reactants? Well, I simply need 3 oxygen molecules. Okay, so let's double check all of that. I need 2 carbons. I have 2 carbons. I need 4 hydrogens. 2 times 2 is 4. And I need 1, 2, 3, 4, 5, 6 oxygens. 3 times 2 is 6. Okay. And then this one, the burning of methane, we did earlier on. So let's see if we can remember how to do this. CH4 plus O2 gives CO2 plus H2O. I've got the right number of carbons. That's fine. I need 4 hydrogens. I only have 2 over here. So I'm going to take a gamble and say I need 2 there. And so now I've got 1 carbon, 4 hydrogens, and I've got 2, 3, 4 oxygens now because I've multiplied that by 2. So with 4 oxygens, I need 2 oxygen molecules. So then you can just do a double check. 2 carbons, sorry, 1 carbon on either side, 4 hydrogens, and then 1, 2, 3, 4 oxygens. Okay. So this one, oxygen and fluorine. Oxygen fluoride plus water gives oxygen plus hydrogen fluoride. Okay, well I have an F2 here, which means I've got 2 fluorine atoms, and I've only got 1 there, so I'm going to take a gamble that I need 2 over there. Now, I've got 2 hydrogens now, that's handy, and I've got 2 oxygens. I've got an oxygen there and an oxygen there. Perfect. If you're not sure about any of these, then write out all of the elements and make sure you've got the same on either side. So for example, here I would say I have oxygens 2, 1, 2. I have 2 fluorines, 1, 2. I have 2 hydrogens. And I would do the same on the other side. I've got 2 oxygens, 2 fluorines, and 2 hydrogens. So it checks out. Okay. And this one then, I have F2 plus H2O gives OF2 plus HF. This looks a little bit trickier because this F2 is fine, but I've got an extra F there. So what I can do is if I multiply this by 2, I'm going to end up with 4 fluorines, 2 times 2, and I've got 2 here and 1 there. But if I multiply this by 2, I've now got 2 fluorines plus 2 fluorines, I have 4 fluorines. So I've now got 2 hydrogens, which matches this, and I have 1 oxygen, which matches that. So my job is finished. I have the same elements here as I do here. Okay, this last one then, methane plus sulfur gives CS2 plus H2S. Excuse my dining room table there. So CH4 plus S. So here, immediately, I can see I've got 2 sulfurs here, 1 there, that makes 3. So I need at least 3 of those, and I've got 1 carbon, that's fine, quite happy with that, and I've got 4 hydrogens, but I've only got 2 here. Right, so if I say I need 2 of those, now I've got 4 hydrogens. Hooray! But wait a minute, if I've got 2 times 2 hydrogens, I've now got 2 sulfurs, so now I've got 4 sulfur atoms. So I change this to a 4. And this is why I suggest using a pencil. And when we move on to the harder ones, I really suggest using a pencil, because this, with my pen, is going to get quite messy. But there you go. Let's just double check we've got everything here. I've got carbon on either side. I've got 4 hydrogens, 1, 2, 3, 4. And I've got 4 sulfurs, 2, 3, 4. Bosh, jobs are good. And let's move on to the scarier ones. These might seem really hard, but it's worth persevering with these. If you can do these, then you're pretty much sorted for balancing equations. So this one then, C2H2 plus O2 gives CO2 plus H2O. It's another combustion equation. Then we have nitrogen plus water gives ammonia plus oxygen. Carbon dioxide plus water gives C2H6 plus oxygen. C2H5OH plus oxygen gives carbon dioxide and water, again combustion. And then finally, ammonia plus oxygen gives nitrous oxide plus water. Sorry, I'm in the way of the water molecule, but that's H2O at the end there. So pause the video and have a go at those. Right, how did you get on? If you think you've aced these, well done. You are on to a winner and you are going to do really well. If you haven't and you are genuinely confused by these, don't worry, these are tricky. But at the end of this video, you will be at a point where you could helpfully, confidently do these equations. Right, so let's get cracking. As I said, the best thing to use is a pencil, not this pen. This is probably going to get messy. It's going to be quite a lot of scribbling out. The thing to do might be to use the audit method. But again, you're going to be scribbling things out. If you've got loads of Lego blocks, the Lego blocks will help you to understand if you've got it right or not. So let's try doing this the way that I approach things. So the first thing I've got is C2H2, and my product, I've got only 1 carbon, so I immediately know I'm going to have to multiply this by at least 2. So now I've got 4 oxygen, so I'm likely to have to multiply this as well. But I've got 2 hydrogens. So I've got 2 hydrogens over here. It's looking promising. But now I've got 1 oxygen here. Let's say 1 oxygen molecule here, which is 2 oxygen atoms. I've got 2 here, and then multiply that by 2, I've got 4, but 1 there. And as I've said to you before, if I've got an odd number, so I've got 4, 5 oxygens, that is not going to work. So what can we do? I mean, I can add as many oxygens here as I want to. I'm not going to get it to balance because I simply need an extra molecule. If I want to add anything here, I'm going to need to add extra hydrogen, which means adding more carbon. So things aren't looking as easy as they were before. So if I want to have more of these, which would make that a nice even number, I'm going to have to add more of these. 2C2H2, it's going to give me enough hydrogen to make 2 water molecules. But now look what I've done. I've got 4 carbons, which means I need to change that to at least a 4. Okay, are you still with me? Hope you are. So I've now got 2 water molecules plus 4 carbon dioxide molecules. Let's audit our things again. I now have 4 carbons. 4 carbons. I have 4 hydrogens. 4 hydrogens. Good. I now have 4 times 2, 8, plus 2, 10 oxygen atoms. Can I make 10 oxygen atoms over here? Yes. I simply have 5 oxygen molecules. And there we go. So this is why it's a bit tricky. You have to go through the process a number of times, and you have a number of iterations before you get it right. But if you have a look at what we've got here, we've got 4 carbons, and I have 4 carbons on this side. I've got 4 hydrogens on this side, and I have 10 oxygens. I have 8, 9, 10 oxygens there, balanced. Okay, so nitrogen plus H2O, water, gives ammonia plus oxygen. Okay, so where is the tricky thing here? Well, I have this NH3, so I need to get this water to turn it into 3 hydrogens. Well, that's not going to happen. But if I have 2 of those, then I can have 6 hydrogens. If I've got 6 hydrogens, then I've definitely got at least 3 of those. But I've got 2 nitrogens, so this is looking good. I've got 6 hydrogens, that's looking good, but I've got 3 oxygens. That's not going to work. Again, I've got an odd number. So what can I do here? Well, what I can do here is have 2 nitrogens, or 2 N2s, which would mean I need 4 of these, and that would give me 12 hydrogens. And to get 12 hydrogens, I would need to have 6 waters. If I had 6 H2O, then I can have 3 oxygens. Okay, so let's check that order again. 2 times 2, that's 4 nitrogens. I have 4 nitrogens. 12 hydrogens, 4 times 3. 6 times 2 is 12. And now I have 6 oxygens. There I have 6 oxygens. So that might seem like a little bit of a stretch, because I immediately just started doubling things. And that's unfortunately where you have to be. That's the mind leap that you have to make. If you start balancing everything and then you find, well, hang on a minute, I've got an odd number, chances are you're going to have to double everything up. Because remember, when you double things up, you're making something that's odd, you're making it even. If I've got 3 apples and I need an even number of apples, if I multiply that by 2, I've got 6. If I've got 5 and I multiply that by 2, I've got 10. Anything you multiply by 2 has to end as an even number. So even numbers are our friend for balancing equations. So let's carry on. Let's have a look at this. CO2 plus H2O gives C2H6 plus O2. Well, immediately I've got the wrong number of carbons. This is the first thing I'm going to try. I'm going to say, right, I want 2 of those. But look, here is where we're going to have a snag. Again, I've got an uneven number of oxygens. So I need to multiply this by an even number, because that's an even number. I'm going to add it to an even number to get an even number out. I need 6 hydrogens. If I multiply this by 3 to get those 6 hydrogens, I'm going to end up with an odd number of oxygens. Okay? And that's not going to be good. I mean, I can try it, but we know that that's not going to work. So I am going to skip a step. Just bear with me. And I'll explain it again before I skip the step. I want 2 carbons here, so I multiply this by 2. Okay? But whatever I do to this, I'm going to have an odd number of oxygens. I cannot have an odd number of oxygens. I need an even number to balance with this. So if I multiply this by 3 to get my 6 hydrogens, I'm going to have 3 oxygens. Even with the even number here, I'm going to have an odd number of oxygens over here, so I'll have 3 plus 4, and that's 7. That's not going to work. I cannot make this into 7. So what I'm going to do instead is I'm going to say, before I even start doing that, that I want 2 of those, which makes 4 carbon dioxides. Now, how many of these do I want? I want 12 hydrogens. So the way to do that is to get 6 water molecules, because that makes 12. Yeah. So now I have 6 oxygens, plus my 8 over here. So that's going to be 4 plus 3 is 7 oxygen molecules. Okay, so let's double check we've got everything we need. I've got 4 carbons here, 2 times 2 carbons, 4 carbons there. I have got 6 times 2, 12 hydrogens here, 6 times 2, 12 hydrogens here. I have got 2 times 4, that's 8 oxygen atoms, plus 6. So that is 14. 7 O2s will give me 14 oxygens. That is that balanced. So you can do all the steps. You could have said, right, okay, well, I need 1 C2H6. I need 6 of those, so I'll multiply that by 3. And then you would have found that actually you had 4 plus 3 of those, which would have been 7 oxygens, and that wouldn't have balanced. And then you'd have realized, well, I need to make this even, and the only way to do that is to multiply this by 2. So you want to try and avoid multiplying these big molecules as much as possible, but that's normally the way that we have to move forward. Okay, so let's look at this beast then. C2H5OH plus O2. This is combustion. It's given carbon dioxide and water. Right, well, immediately we can see that we've got an odd number of oxygens here. But over here, you also have an odd number of oxygens. This makes me cry, but it's okay. Odd number on one side, making an odd number on the other side. We're fine. But I've got a C2 here. I need to make 2 carbons. So I have 2 carbons over here. C2H5OH plus O2, CO2 plus H2O. Right, let's have a look at hydrogen. That's the next one. I've got 5 hydrogens there plus 1 there. That's 6 hydrogen. To make 6 hydrogen, I want 3 of those. Okay, how much oxygen do we have now? I have got 3 plus 4. So I've got 7 oxygen atoms. So let's see how many I've got over here. I've got 3. But if I make this 6 oxygen atoms by having 3 oxygen molecules, now I've got 6 oxygen atoms plus 1. So I have 7. So 2 times 2 there, 4, plus 3, 7. I have 7 oxygens, I have 6 hydrogens, and I have 2 carbons. That wasn't as scary as it looked. Hooray! Okay, so if you didn't try this before, I want you to pause the video at this point and try this final one. And even if you did, I want you still to pause the video and go through this and see if your answer hasn't changed. Okay? See if you get the same answer each time after going through those other ones. Okay, welcome back. So this does seem at first glance to be fairly straightforward. I've got some nitrogens, I've got some hydrogen, I've got some oxygen, and the numbers don't look too bad. Look, I've got 2 oxygens there, 2 oxygens there, 1 nitrogen, perfect. what could go wrong? So I just need to balance up these hydrogens, right? But odd number here, even number here. Right, okay, so how can we even up the hydrogens? Well, the first thing we do is we could multiply this by 2. I multiply this by 2, I've now got 6 hydrogens. Hooray, that's an even number. But whatever I do to this, I've now done to this with 2 nitrogens, making 6 hydrogens, so there's 3 of those. So now, have we done it? So I've got 2 nitrogens, and I've got 6 hydrogens, 3 times 2, 3 times 2, and now I've got 2 plus 3, which is 5 oxygens. I can't make 5 oxygens. So where do we go from here? Well, I want to keep this even. So my first thought is to double this up. That's where I want to go. So I'm going to get rid of that. To double that up, I'm going to go to 4. And to do that, I need to double this up. So now I've got 12 hydrogens, which means I'm going to end up with 6 water molecules. Okay, I told you this was going to get messy. Right, so immediately we can see even numbers here. That makes me happy. Even numbers are good. I've got 4 oxygens here, 6 oxygens there. That's a total of 10 oxygens. This is O2. So to make 10, I multiply that by 5. Are we done? Let's have a look. I've got 4 nitrogens. 4 nitrogens. I've got 4 times 3, 12 hydrogens. I've got 6 times 2 over here, 12 hydrogens. Perfect. I've got 10 oxygens here. I've got 4 plus 6 oxygens there. That's 10 oxygens. Boom. Mic drop moment, but that didn't really work very well. So there we have it. Those 15 equations all balanced. Practice, practice, practice. With the understanding of what you're doing, if need be, get yourself some little Lego blocks, any Lego blocks, or even marbles of different colours, as long as you can arrange them and you know which atoms are which. So in my example, I had a yellow and a red and a white, and I could say, well, that was carbon, this was oxygen, this was hydrogen, for example. You could do it with marbles, you could do it with counters, you could do it with bits of card, bits of paper, you could do it with drawings, anything you like. And that will help you to understand whether you've got it right or not. The simple thing that you're trying to do is you are trying to make your reactants make your products. If you can't make your products from the reactants that you have, then you've done it wrong. That's what we're trying to do. That's what we're trying to achieve. That's the ultimate goal here for balancing equations. So some students say to me, I don't really understand what I'm trying to do. So that's what we're trying to do. Let me show you a couple of things that students will try and do. So this is a couple of misconceptions and some things. So everything from this point onwards, I'm going to do wrong. Okay, and I'm going to put a big X next to it as well. So let's start with this same equation. This is a scary equation, so students might be tempted to do this. So we start with the equation, and O plus H2O. Right, okay. Well, that's simple, isn't it? I've got a nitrogen there, and I've got 2 oxygens, and hydrogen. Well, I just need to change that to a 3. No, you can't do that. That's breaking the laws of physics and chemistry, which is physics in a jar. You cannot change the molecules. What you're doing here is you are fundamentally changing the water molecule. You cannot have an oxygen with 3 hydrogens attached to it. Simply cannot exist. Other things that they'll do is they will try and do this, maybe for fun. Now I've got 2 nitrogens on either side. No, wrong. You cannot, again, change those molecules. The only thing you can do is add multipliers at the beginning of the molecules. Okay, you can have 2 lots of NH3 and 2 lots of O2, or 5 lots of O2, but you cannot have any O5s, for example. And that's what I was hoping to demonstrate with the Lego. So this one, for example, NH3, oops, it is upside down. This is NH3 because it's got 3 atoms of hydrogen and 1 atom of nitrogen. That's NH3, that's ammonia. You cannot change that, it's always that. But what you can do is you can add more of them. So if I want to, I can say, right, well, I can have 2 NH3s. And I can just add more and more and more and more. What I cannot do is I cannot change the fundamental nature of this because it's inconvenient to my maths. I can't make NH4. Okay? It just isn't possible. So the only thing you can do is add more of the same molecule. Right, I'm hoping that that has helped in some way. If you are still confused or if you have any questions, leave a question in the comment box down below. Please do like this video. It does help the algorithm quite a lot. Good luck with everything and stay safe. I'll see you soon.